Hello, Elena. Today we couldn't think of what to study, so we decided to study studies. So here we are. The studies that we are looking at are first observational studies. And there are two kinds: survey, like we have been discussing, and watching. Watching is just when there's an observer in the corner and observing behavior, taking notes, and so forth. Neither of these, observer or surveyor, should be influencing the results or actions of the people in the study. All right, the observational study is done, and we're going on to the next kind of study, and that is the experiment. The experiment is when a treatment is imposed and a response is measured. Just like in science class, you're going to change something on your subject, on a person, on an animal, on a thing, and you're going to watch at the response. So a treatment is imposed and a response is measured. It's called an experiment. Experiments are extremely important in science and in statistics. It's the only way to determine causation. So far I said everything we see, association is not causation, this is not causation, that is not causation. Experiment will determine causation. It's very powerful. It is the only way to determine cause and effect. Let's take an example of that. NIH stands for the National Institute of Health. And it turns out that they observed, they did not experiment, but they observed that women, after they were in their 50s, they stopped producing estrogen. So all the doctors said, take replacement hormones, and you can sleep at night, you won't have hot flashes, you won't be irritable, blah, blah, blah. So they gave them estrogen. It's called hormone replacement. And it was becoming very favorable with the community because a side effect happened, and that is these women were having less heart attacks. In fact, I remember people telling me way back when I was 50 to take it. They said life will be so much easier and you won't get heart attacks.
That's a good side effect.
Yeah, very good side effect. No heart attack. I'll take one. But I refuse to do it. I'm just not a medicine taker. And so it's turned out now that what they did was an experiment. These were observations. The experiment was the NIH developed a large group of females and randomly assigned them to, they agreed to this of course, to hormone replacement or a placebo, which was not hormone replacement. And over many years they observed the results of these two groups of women, and guess what? Exactly no change in heart attacks percentages. So what was going on up here in the observational study? Well, what happened was the women who were coming to the doctors in the first place and wanting help with their change of life issues or taking the hormone replacement were people who were attentive to their health, had a doctor, went to the doctor, had some money, had some, I don't know, a lot of different things going for them, and they're just observing those people and saying, well, they're not having heart attacks. But it was not set up because there's a lot of lurking variables that were contributing to that. When they did a true experiment where you could actually determine causation, there was no difference in number of heart attacks. So did I make a right decision?
Yeah.
Yay. All right.
It wouldn't have been bad.
All right.
Were there negative?
Yeah, it weren't negative effects, so it didn't really.
I don't know. Probably, but I didn't mention it in
Well, did you get a heart attack?
So what?
Did you get a heart attack?
No, not yet.
And you're
We're
good.
never gonna have
I know.
Yeah, you'll never
I
die.
hope not.
This cow will never die.
All right. So, what could you say a lurking variable was? Maybe they went to the doctors more often. I don't know. They attended their health issues more closely. Maybe they ate better and exercised.
It's
Blah
like the whole,
blah blah blah.
helicopter
There's so
thing.
many lurkers possible that I can't believe the NIH was actually saying that. are observing that and putting that, I don't know if the NIH did the experiment, but doctors in general were observing that and making that recommendation on very poor evidence. All right, anyone who took a high school level statistics class would know better, right? So, all right, another problem I want to mention while we're looking at studies, well, this actually can happen with an experiment is a good thing, but it can have a problem. Sometimes there are two variables affecting the response and you're not really aware of it. So we'll call that confounding. Confound it. Confounding. Two variables are affecting the response and you can't tell which is which. Two or more. So you have more variables going on than you want. In an experiment, you only want one variable to be changed in the group. And if there's more than one, you have confounding and you can't really make a clear cause and effect statement. Observational studies, this kind often have confounding. That's what happened with the women and their hormone replacement. There were other lurking variables. When you're talking about experiments, there are three terms that we need to know, and they almost define themselves. So let's see, go through them quickly. The first one is what we call the condition that's applied. As I told you, for an experiment, you have to change something on a group, and that is called the treatment. So the treatment is a new condition that is applied to a group. Something is changed. Something is added. Something is subtracted. That's called the treatment. And we'll look at some examples of these so you understand more clearly what a treatment is. The individuals in the experiment, they have to name them, and they are called experimental units. How are we doing for time, Bailey?
We still have 3 minutes until it's done.
Okay, good. The experimental unit are the individuals in the experiment. If they're people, we usually call them subjects. If they're animals or things, we call them experimental units. Subjects equal people sometimes. We don't often call animals our subjects. They are experimental units. So when I give you an experiment, I want you to tell me what the treatment is and what the experimental units are. And the last language I need to teach you for experiments is we are going to rename explanatory variables. Remember, those are the ones that explain the response variables. We're often going to call them factors. So if I say, what are the factors in this experiment, I'm really just asking you, what is the explanatory variable? And these factors can have different levels. All right, I'll give you an example. Wait a minute while you catch up your notes, and then I will give you an example of an experiment, and you can tell me what's the treatment, who or what are the experimental units, what are the factors, and what are there any levels in this experiment? All right. All right, listen to this experiment and see what you think. Ready? All right, an experiment is going to be conducted, and all subjects are viewing a 40-minute television program. And that includes ads for a certain object, say it's a camera. Some subjects are going to see a 30-second commercial. Some are going to see a 90-second commercial. And some are going to see the commercial one time. And it could be 30 or it could be 90. And some are going to see them 3 times. Some of them are 1 minute and some of them are 90 seconds. 30 seconds, 90 seconds. And some are going to see the commercial 5 times. That's the show I watched last. 5 times you're going to see the commercial. So, after viewing all of that, the subjects are asked at a later time if they recall the commercial, and then they're going to be asked what their attitude is toward the object, the camera, favorable or non-favorable within a score of 1 to 10, and do they have any intention to purchase it. So, all right.
It's a bit obvious.
Let's the amount of factors involved.
Time.
Time. Beep.
Okay, we're gonna